Assalamualaikum warahmatullahi wabarakatuh and hello students. So in this video we will learn about matrices. Okay, chapter 5. So in chapter 5 there are 5 topics altogether. So the first one is introduction, second one is operation on matrices. Okay, and then we will look into determinant of matrices. The fourth is the inverse matrices, and lastly we will learn how to solve the system of linear equations. Okay, 5.1 introduction. A matrix is a rectangular array of numbers arranged in rows and columns and enclosed in parentheses, brackets or braces. Generally, a matrix A with m horizontal rows and n vertical columns, m times n, can be written as follows. Okay, so you can see the table A, okay, on your right. The numbers aij in the matrix are called the elements of the matrix. Okay, so element in the ith row and the jth column. The order or dimension of a matrix is given by stating the number of rows and then the number of columns in the matrix. So basically, okay, you have here is your row. So this is row 1, this is row 2, and then you have until row m. Okay, and then the vertical is your column. So you have column 1, column 2 until column n. So for example, this element A11 is an element in the first row, the row 1 and the column 1. Okay, and another example, let's say this A2j. The 2 is actually the row, so this element is in the row 2 and column j. Okay, and so on. Okay, now we will look into the types of matrices. Okay, this is a specific matrix that has its own name lah. Okay, so the first one is row matrix. So row matrix is a matrix consisting of a single row or a matrix with 1 times n order. So there's only one row in a row matrix. Okay, for example, this 2 negative 2 7 is 1 times 2 because you have 2 columns. Okay, and then this example negative 1 0 2 3 is actually 1 times 4 because you have 4 columns. And actually you don't have to write these commas in between elements. Okay, so you don't need to write the commas in between the elements. You just have to write negative 1 0 2 and negative 3. Okay, the second one is a column matrix. So column matrix is a matrix consisting of a single column or a matrix with m times 1 order. Okay, so basically in a column matrix you have one column here. All elements have only one columns. All matrices only have one columns. However, there will be several rows. Okay, so for this one there is 2 times 1 because you have 2 rows and 1 column. This is 3 times 1 and then this is 4 times 1. So remember, you have to put the rows first and then your column. Okay, the third one is a square matrix. Square matrix is a matrix with an equal number of rows and columns. So it means your m is equals to n. Okay, the number of rows equals to the number of columns. The leading diagonal of square matrix is the diagonal containing the number of the upper left to the lower right. Okay, so this is 2 times 2 square matrix. This is 3 times 3 square matrix. Okay, so what is the leading diagonal? The leading diagonal is this one. This is what we call leading diagonal. The upper left to the lower right. Okay, the diagonal containing number from the upper left to the lower right. Okay, the fourth one is the null matrix. So null matrix is actually a matrix with all its elements are zeros. Okay, so you have here a column matrix, right? Because you only have one column. but since all the elements are 0, so we call it null matrix as well. So this is 3 times 1. This is a square matrix, 2 times 2, but since all the elements are zeros, then we call it null matrix as well. So this is also a square matrix, 4 times 4, which is a null matrix because all elements are 0. Okay, there are a few more. Okay, the fifth is the identity matrix. Identity matrix is a square matrix. Okay, so the square matrix in which element in the leading diagonal is equal to 1 and the remaining elements are 0. So leading diagonal is this one, all are equals to 1, all are equals to 1. Okay, and it must be a square matrix, which is 2 times 2 and 3 times 3. Okay, the diagonal matrix is a square matrix, again a square matrix, in which all elements are 0 except the diagonal element. Okay, so diagonal element here is not 1. If it's equal to 1, then it's become identity matrix. Okay, however, this is not equal to 1, but since the diagonal matrix is not equal to 0, but then the other elements are equal to 0, then we call it diagonal matrix, because only the leading diagonals has a value. Okay, the others are zeros. 7 is a symmetric matrix. Okay, again it's a square matrix such that the transpose of a matrix is equal to that matrix itself. Okay, for example, if it's a B transpose, then it equals to B itself. Okay, so what is transpose? Transpose is actually when the element of the rows become element of the column. Okay, in the transpose. For example, let's say this is 9, negative 2, I call it A, then my A transpose will be 9, negative 2. This column will become rows here, and then this column will become rows here. Okay, but then since it is actually the same things happen, the same matrix, which is A equals to A transpose, then we call it symmetric matrix. Okay, this is as well. Okay, if you transpose the 372 here, there's also 372, and if I transpose 7, negative 1, 0, then it becomes 7, negative 1, 0 also. And if I transpose 2, 0, negative 6, here will be 2, 0, negative 6 as well. So it is a symmetric matrix. 8 is the upper lower triangular matrix. It is also a square matrix where all the elements below and upper the diagonal the main diagonal are zeros. Okay, so the main diagonal is here, the main diagonal is here, so this is what we call upper triangular matrix. This is also upper triangular matrix. Okay, if upper triangular matrix, then the below elements are all zeros. So here zeros, here also all zeros. Okay, let's look into this example. Classify the following matrices according to the types of matrices. Okay, raw matrix. We have known that a raw matrix is a matrix that only contains one row. So there's only C. The answer for this is only C. Second, a square matrix. So square matrix is a matrix with m's equals to n, or the rows equals to the columns. The number of rows equals to the number of columns. So for A, we have 2 times 2, so it is a square matrix. For B, we have 3 times 3, so it is again a square matrix. C is not a square matrix, C is a row matrix. D, another square matrix, 2 times 2. And E is not a square matrix because you have 3 times 2 here. Okay, what is symmetric matrix? Okay, remember symmetric matrix is when your, let's say your matrix T transpose will be equals to T as well. Okay, the transpose of your matrix will be equals to itself. Okay, so is A transpose equals to A? So if we transpose A, then I will have, okay, remember your rows will become your column in the transpose. So it's negative 2, negative 1 here, and negative 4, 0 here. So it is not equals to A, the first row is negative 2, negative 1. However, A transpose, the first row is negative 2, negative 4. Okay, how about B? So here, 1, 0, 0 will become 1, 0, 0 in the column. Okay, then 3 over 4, 2, 0. And then 8, negative 1, 3. So it is not equals to B. Okay. Okay, C is not a symmetric matrix because symmetric matrix must be a square matrix. Okay, C itself is not a square matrix to begin with. Okay, D transpose is again 0, 0, 0, 0, which is itself D. So D is a symmetric matrix. E transpose, again, E cannot become a symmetric matrix because it is itself not a square matrix. Okay, for a symmetric matrix it must be a square matrix first. Okay, next, D is the lower triangular matrix. Okay, so lower triangular matrix is when your matrix consists of a triangle shape, okay, in which the triangle has an element and all others are zeros. Okay, so if it's lower triangular, then the triangle must be in the lower form, which is B lah. Okay. Okay, let us see this example. Classify the following matrices according to the types of matrices. Okay, now the column matrix. Column matrix is a matrix that consists of only one column, which is here is only R. Okay. Identity matrix is when the main diagonals is equals to 1. So you have P here. Diagonal matrix is when the main diagonal has a value, the element of the main diagonal has a value, and all other are zeros. So you have P and Q. Symmetric matrix is again you have to do the transpose. Okay, so is P transpose equals to P? It is, because when you transpose your P, you will have P itself. Okay, how about Q? Q transpose will be 5, 0, 0, 0, 1, 0, 0, 0, 8, which is Q itself. R is not symmetric because it is not square. S, so S transpose will be 4, 0, 6.35, negative 9, which is, it is not equal to S. And then T transpose will be, okay, this column will become rows 3 to 6, and then this one will be 2, negative 3, 7, and then this one will be 6, 7, negative 1, which is, it is again equals to T itself. So we have PQT as a symmetric matrix. Okay, lastly, upper triangular matrix. Okay, upper triangular matrix is only S because this is the triangular. The lower elements are zeros. Okay, next we will look into equal matrix. Two matrices are said to be equal if they have the same size and their corresponding entries are equal. For example, negative 4 is equal to negative 5 plus 1. It is equal here. Okay, and then the element here is also equal, and then the elements here are also equal. Okay, and the same as below. 1 is equals to 1, 2 is equals to 2, and 3 is equals to 3. If each element, okay, are equal, and then the matrices have the same size, then we call it as an equal matrix. Okay, it must have the same size, same dimension. So if you look into the second example, it is not equal. Why? Because this is 2 times 3 and then this is 3 times 2. It is not in the same dimension. Okay, so further, the green one also is not equal since the corresponding elements in row 2, so here is not equal to here. Okay, so to have an equal matrix, every element must be equal. Okay, if this matrix equals to this matrix, find the values of x, y, and z. Okay, so it says equality here, means these 3 must be equal to these 3, it's already equal. Then if you want to find x, 2x must be equal to -2. Okay, then you find x equals to -1. And then if you want to find y, your y minus 4 must be equals to 7. Okay, actually it must be equals to 7 here, so y must be equals to 11. Okay, and then if you want to find z, your z over 5 must be equals to, again it is 15 here, so it should be equals to 75. Now in this video as well, we will learn about operation of matrices 5.2. So just like ordinary algebra, matrix algebra has operation like addition and subtraction, scalar multiplication, and multiplication between matrices. So if we add 2 matrices, so we just add the elements. Okay, so the elements in the same rows and same columns, just add it together. So in order for 2 matrices to perform an addition, it must be in same dimension, it must have same order. Okay, so here A plus E, then you will have A plus E together with B plus F, then you will have B plus F, and so on. To subtract is also the same. Okay, it must be in the same order and the same element in the same row and the same column. You subtract it together. So A minus E here, A minus E, and then let's say D minus hash here, so it becomes D minus hash, and so on. Okay, so for multiplication, multiply each row by each column. So for multiplication is actually AB. Okay, you multiply with EG. So A times E plus B times G. So you have here A times E plus B times G. Okay, and then second one, again the AB with F hash. Okay, AB with F hash. So A times F plus B times hash. So here and here we'll have this one, and so on. Okay, so for the first matrix, it is you consider the rows. For the second matrix, you consider the column. Okay, so this one will be CE times CE plus DG, and then this one will be C half plus D hash as this one. Okay, so details on addition, subtraction, and multiplication on matrices can be found in the next slides. 2 matrices A and B of the same order, okay, can be added or subtracted by adding or subtracting the corresponding elements of A and B. For example, if A equals to A, B, C, D, and B equals to P, Q, R, S, hence A plus minus B is equals to this one, as you can see. Okay, so the corresponding element of A is P, the corresponding element of B is Q. Okay, the corresponding element of C is R, and lastly the corresponding element of D is S. So there are properties of matrix addition. Okay, if matrices A and B have the same order, so if you there's a commutative law, means if you add A plus B or B plus A, the answer will be the same. Okay, then there's also associative law, in which A plus B plus C is equals to A plus B plus C whenever the bracket you put the bracket in. Okay, let's say you put the bracket in B plus C, it is the same as if you put the bracket in A plus B. So that is associative law. Okay, now let's look into scalar multiplication. So for a matrix A and real number K, the matrix Ka is obtained by multiplying each element in A by K. Okay, so it is, the K is a scalar, so it means that this element K you multiply with each element in the matrix. So you have Ka, Kb, Kc and Kd. Okay, the theorem or the properties of scalar multiplication, there's a distributive law as you can see here. Okay, K times A plus minus B is equals to Ka plus minus Kb. Okay, and also H plus minus K, where H and K is a scalar, and then the A is a matrix. Okay, then it is also equals to HA plus minus KA. Okay, and also the associative law, if you multiply H with Ka, it is also the same answer if you multiply HK first and then you times with your matrix. Okay, so there's a distributive law and associative law in scalar multiplication. Okay, let us look into this example. Okay, find the following matrices where possible. Okay, A plus B, A plus C, C minus A, 3A, 4B, C plus B, and 3A plus 2C. Okay. Okay, so this is the example just now. Okay, A, B, and C are matrices. So A is a matrix of 3 times 3, B is a matrix of 3 times 2, and C is a matrix of 3 times 3. So first question asks us to find A plus B. A plus B does not exist simply because it is not in the same order. Okay, as I said before, this is 3 times 3. However, this is 3 times 2. Okay, A plus C, the answer is that one. Okay, you may check. C minus A, okay, you may check as well. And 3A, okay, the 3A means you times 3 with every element in your matrix A. Okay, E 4B means you multiply each element in your B matrix with scalar 4. And F asks a question of C plus B. However, C plus B does not exist because it is not in the same order. Okay, B you have 3 times 2 and C you have 3 times 3. And then G, 3A plus 2C. Okay, so you already find your 3A in D here. Okay, and then plus 2C. So you have to times 2, okay, the scalar 2 for each element in your matrix C, plus, and then you'll get this answer. You may do it first and you may check your answer. Okay, there is another example. Given the matrices A, B, C, find the following matrices if exist. Okay, A minus B, B minus C. Okay, second question, suppose D is equals to P negative 7Q, R 4 negative 15. Find the value of P, Q, and R if D plus B equals to A. Okay, you may answer this question first and check whether your answer is correct or not. Okay, so this is the answer for the example just now. You have A, B, and C. And then the first question asks you to find A minus B. Okay, so you just minus each element of A, subtract to each element of B. B, the question asks you to find B minus C. However, it does not exist because it is not in the same order. And the question number 2 asks you to find PQR if D plus B equals to A. So you have to do an addition matrices first, and then we'll find that you equal your matrix. Okay, the second question asks you to find PQR if D plus B equals to A. So you have to add the matrices D and B, and then you do an equal matrix in between D and B and A. So does you answer that correctly? Okay, so this is an exercise for you. Okay, please do it first, and then you may check your answer with your lecturer. Okay. Okay, next we move into next operation, which is multiplication. The product AB. Okay, now the A and B are both matrices. Okay, the product AB is defined only if the number of columns of A is equal to the number of rows of B. Okay, so means if you have P times Q and then B is Q times R, then you can do the multiplication process and you will get P times R there. Okay, the new dimension of your matrix will be P times R. So the Q here, the rows, the column must be equals to the rows here. Okay, the column must be equals to the rows here, and then this is your answer, P times R. Okay, so to check whether the dimension of your matrix is correct after multiplication, then you may check as it is. Okay, multiplication is done by first taking a row from the first matrix and a column from the second matrix. Second, multiplying the corresponding elements from the row and column. And third, adding the products. Okay. Okay, let's look into the process. So the multiplication is done by taking the row of the first matrix and the column of the second matrix. Okay, you do the addition and multiplication to this element. Okay, so the first one times with the first one plus the second one times with the second one. So then we have AP times plus BR. Okay, then you have here your AP plus BR. Okay, so it is the same as then you repeat again with the row and column. Okay, then you repeat again until all the rows and column has been multiplied. Okay, so here you have QS, so A times Q plus BS, A times Q plus BS, and then here you have CD. Okay, so you repeat again, C times P plus DR, C times P plus DR, and C times Q plus DS, C times Q plus DS. Okay, so remember, the first matrix only the row, the second matrix look into the column. So the theorem of the properties of matrix multiplication, again, it is associative law. It is also a distributive law. However, the commutative law does not hold. Means if you times AB, it is not equal as you times BA. Okay, the answer is not the same, it's a different answer. Okay, next operation is matrix transpose. The transpose of a M times N matrix is the N times M matrix obtained by interchanging the rows and column. The transpose of A is denoted by A transpose. If A equals to A, B, C, D, then A transpose equals to A, C, B, D. Okay, as I told you before, in a transpose, the row becomes a column. Okay, so the BD rows become the column BD in the transpose. Okay, so the theorem of properties of the transpose matrix, okay, A plus B transpose equals to A transpose plus B transpose, and A transpose transpose equals to A. Okay, means if you transpose the transpose matrix again, then you will get the your original matrix. Okay, let's look into this example. Given the matrices W, X, Y, Z, okay, then the question, we have A until K questions here, and the answers are given in the lower right of this video. Okay, you may check your answer. Okay, let's say we do a few of it. I'll show you how to do a few of it. Let's see J and K. Okay, the Y transpose, X transpose, and Y transpose. Okay, so this is Y 2, -1, 3, and this is X 1, 4, 3, 0, 1, 1. Okay, so for Y transpose means the column becomes the row. Okay, so now the column matrix become the row matrix of Y. And X transpose, okay, for X transpose you have 1, 4, 3, 0, 1, 1. So interchange the column to matrix. We'll have 1, 0 here. Okay, and then you have 4, 1 here, and then you have 3, 1 here. Okay, so the question asks you to multiply Y transpose with X transpose. We already have 2, -1, 3 with 1, 0, 4, 1, 3, 1. Okay, let's check the dimension. Can it be multiplied? So for the Y transpose we have 1 times 3, and then for X transpose we have 3 times 2. Okay, so the column for Y transpose is equals to the rows of the X transpose. Okay, you check just now, you just check that this 3 is equals to 3, and then your answer must be 1 times 2. 1 times 2 mean you will have a matrix of 1 row with 2 columns. So A, B, there's only 1 row, and then there's a 2 columns, C1, C2. Okay, so this is your answer, 7, 2. Okay, how to do the multiplication of matrices? Okay, again, you times your row with your column. Okay, times the row with the column. Okay, so 2, -1, 3 here, you times with 1, 4, 3 first. Okay, which is 2 times 1 plus -1 times 4 plus 3 times 3. Okay, and then we'll get 7. Okay, the second one is another, again, the 2 times 2 -1, 3 with 0, 1, 1. Okay, so you have here 2 times 0, -1 times 1, and 3 times 1, and then the answer is 2, which is the 1 times 2 matrix. For K, y multiply with y transpose. Okay, so your y is 2, -1, 3 in terms of column matrix. Now when you transpose, it becomes the row matrix, 2 times 1 times 3. Okay, now the column here is 1 and the row here is also 1, so we can do a multiplication, and your answer, you must get 3 times 3 matrix. Okay, so again 2 times 2, 2 times -1, and then 2 times 3. The 2 times 2 will get 4, the 2 times -1 you get -2, and then the 2 times 3 will get 6. Okay, and then repeat with the next row and each column. You may try. Okay, last example in this video. Okay, given the matrices again A, B, C, find the following matrices if exist. Question number 1 until 5. Okay, you do it first and I'll show you the answer later. Okay, so if you have done, this is the answer for the example just now. You may check, and if you get the wrong answer, you may do it again, and if you slightly don't understand, you may ask your lecturer. Okay, so that's it for this video. The matrices, we have learned about the types of matrices, we have learned about the operations in matrices. Okay, so next video we will learn about determinant of matrices as well as inverse of the matrices. Stay tuned. Thank you for listening to this video. So I hope you can do the exercises, and please remember, if you don't know how to do an example or an exercise, do ask your lecturer. You may do a study group as well with your friends. Okay, so thank you everyone. We'll see you in the next video.